Okay, so we are here. Mohr circle. All this transformation which we have just now learned can be explained using Mohr circle. You have already done Mohr circle for stress, so it is very similar to that. It is very similar to that. So this is the Mohr circle. So how to draw this Mohr circle? First, this is your take your epsilon axis, and this is your gamma axis or gamma by 2 axis, whatever you say. Now epsilon x and gamma by 2 would be plotted here. So epsilon, this is epsilon xx, and positive gamma xy by 2 would be plotted in the downward direction, because gamma by 2 or gamma whatever you say is in the downward direction. So if you have positive gamma xy, then gamma xy by 2 has to be drawn in this direction. Then epsilon yy and minus gamma xy by 2. Better put a minus here. Okay, so here epsilon yy and is minus gamma xy by 2. Now this is your diameter, and this point is the coordinate of this point is epsilon average 0, because this has to be epsilon yy plus epsilon xx divided by 2. So this is the center of the circle. So with this center of the circle and this as diameter, you draw as a circle. Okay, and now you see, so now just notice that how much is this? This is gamma xy by 2, and how much is this? This is epsilon xx minus epsilon average. So what is this length? This is epsilon xx minus epsilon average whole square. What is epsilon xx minus epsilon average? Epsilon xx is minus epsilon average, that is epsilon xx plus epsilon yy by 2, that is epsilon xx. So if you do this, that gives you epsilon xx minus epsilon yy by 2. So this is epsilon xx minus epsilon average is epsilon xx minus epsilon yy by 2, and this is gamma xy. So this radius is nothing but epsilon xx minus epsilon average square plus gamma xy by 2 square. So what is the coordinate of this point then? So what is the coordinate of this point? The coordinate of this point is epsilon average plus this r, and this is sigma, this is epsilon 1 or epsilon 1. So this is one principal strain, and the other principal strain is here. What is this? This is epsilon average minus r. So epsilon 1 is epsilon average plus this, and epsilon 2. So these are called the principal strains. So these are the principal strains. So whatever you get from your deduction, so that is represented by the Mohr circle. So this is epsilon 1 I have shown here. So this is epsilon 1 up to this point, and epsilon 2 to this point. This is sigma average. Now this is, suppose you draw this as your x and this has your y. So this is parallel to x, this is parallel to y. And for this blue plane is there. For this actually, so this plane represents this xy. Now this is the principal plane. So to get the principal plane, you need to rotate the xy plane by 2 theta in the Mohr circle. That means in the anti-clockwise direction. That means in actual figure, you have to rotate it by theta. So if this is 2 theta, if the rotation in Mohr circle is 2 theta, the actual rotation is theta. If this is anti-clockwise, this is also anti-clockwise. So this is actually the location of the principal plane. So there are some examples, and these examples are taken from a popular book, Mechanics of Solids by Hibeler. So you can refer Mechanics of Solids by Hibeler. So this example is taken from here. So epsilon xx is 250 microstrain, epsilon yy is minus 150 microstrain, and gamma xy is 120 microstrain. You have to determine the principal strain. So how to draw epsilon? Suppose first the epsilon axis and the gamma by 2 axis. So epsilon axis, so this is 250 and this is 250 and this is 60 because gamma x by 2. Since this is positive, you have to go downward. So this is 250, 60. And now here, so here I think we should put minus. So this is minus 150. So this is minus 150 with respect to this origin, minus 150 minus 60. Now you get the diameter, and the center would be at 250 minus 150 whole divided by 2. That means 250 minus 150 is 100. 100 divided by 2. So at 50, 0. So with this as the center and this as the radius, draw the circle. So what is 2 theta? 2 theta is tan inverse 60 divided by 250 minus 50. That is 200. So tan theta is equal to 60 by 250 minus 50. So 2 theta equal to this and theta equal to 8.35 degree. So 2 theta equal to 16.70 degree. That means this blue plane, if you rotate it by 8.35 degree, you get the principal plane. And what are the principal values? The principal values, so you find out the radius. The radius is this square. So this is 250 minus 50 square plus 60 square root over. So this is the radius. So with 50 you add this. With 50, so yeah. So this is the average stress from here to here. With this you add the radius. This is also radius. If this is the radius, this is also the radius. So with 50 you add the radius. So 50 without the radius, this is the maximum principal strain and this is the minimum principal strain. So 50 minus radius. So this is the principal strain. Good. So this is another example. This is epsilon xx is minus 300, epsilon yy is minus 100 and gamma xy is 100. So epsilon xx is minus, so this is your epsilon axis and gamma axis or gamma by 2 axis. So you go minus 300 in this direction and then in the downward direction, because gamma xy is positive and for gamma xy downward is positive. So this is gamma xy by 2. So this point is minus 350. And what is the center? The center is at minus 300 minus 400 by 2 is minus 200. This is the center. So with this as center and this as radius, you draw a circle and now determine the state of strain 20° clockwise from the given position. So this is the given position. So this is the given position. From here you go 20° clockwise. That means in the Mohr circle you have to go 40°. So this green plane is the x-dashed plane and the strain state at this x-dashed plane is required. So either you can do it graphically or you have to do it trigonometrically. So this 2 theta 1, so radius you have already got. This 2 tan 2 theta 1, tan of this 2 theta 1 is 50 divided by this, 50 divided by this. So this is minus 300 and this is minus 200. So this is 100. So 50 by 100. So 50 by 100. So this 2 theta 1 is 26.57 degrees. So this is 26.57 degree. That means this is 40 degrees. So 40 minus 2 theta 1 is giving this pink one, which is 13.43 degree. Okay. Now how to get the stress state at a point? So you how to get the stress? You have got the radius. You have got the radius. Okay, so minus 200 and then minus r cos 13.43 degree will give you epsilon x dash x dash. So epsilon x dash is minus 200, that means the center of the circle, then again minus r cos 13.43 degree, and gamma x dash y dash is minus r sin 13.43 degree. Gamma xy is minus because it is above the epsilon axis and in the negative gamma axis. Now strain rosettes. So 45° strain rosette, which is also called the rectangular strain rosette, and 60° strain rosette. So these are actually strain gauges. So strain gauges they measure the strain along the axis. They measure the normal strain along the axis. The strain gauges, they measure the normal strain along the axis. Now how do you get multi-axial strain using or plane strain using strain gauges? So what we do is we use 3 strain gauges arranged at a particular angle, and by measuring these 3 normal strains in these 3 given directions. For the rectangular rosette or 45° rosette is in the x direction, y direction, and the 45°, and along the axis 45° aligned with both x and y along this direction. We measure normal stress in these 3 directions and we find out the strain state at that point. That means we find out epsilon xx, epsilon yy, and gamma xy. So this is very simple. So this is the formula which is using. So for 45° rosette, theta equal to 6, theta equal to 0 degree. So epsilon a is, so let us call the strain along this epsilon a. So epsilon a is, put theta equal to 0 degree for this. So this is epsilon xx. So epsilon a is epsilon xx. Now put theta equal to 45° and again use the formula. Put it in this formula. So 2 theta is 90°, sin 2 theta is cos 90°, sin 90°, and cos 90° is 0, sin 90° equal to 1. So epsilon b is this, or gamma xy is 2 epsilon b. Gamma xy is 2 epsilon b minus epsilon xx plus epsilon yy, and theta equal to 90°. Theta equal to 90° for the third one. For the third one, theta equal to 90°. 90° means you put 180° here. This is minus 1, this is 0. So from the third relation is this epsilon yy is epsilon c. Now here you put epsilon xx as epsilon a, and epsilon yy as epsilon c, and you get, so from this number 2 relation is this. So once you get epsilon a, epsilon b and epsilon c, you can find out gamma xy, gamma yy, gamma xy, epsilon yy and epsilon xx. So another is the 60-degree rosette. So we proceed in a very similar way. Here 0 degree, 60 degree, 120 degree. So you put in this formula theta equal to 0 degree, theta equal to 60 degree and theta equal to 120 degree. Get the three relations, solve for epsilon xx, epsilon yy and gamma xy, and here you get these three relations. So epsilon xx is epsilon a, epsilon yy is this, and gamma xy is this. So here we stop our discussion on plane strain.